In my previous video, I introduced the topic of solving and evaluating formulas. And in this video, I want to sort of extend on that and solve a few go through the solving process of a few problems. So, number one, we're given this algebraic formula, x equals w plus y plus z, all divided by 5, and we want to solve for y. And solve for y means we want to isolate the y. We want to take this equation and rewrite it in the form y equals something. You want to isolate the y or get y by itself. And we have two rules we need to apply. We have the addition rule that says addition and subtraction cancel each other out, and we have the multiplication rule which says multiplication and division cancel each other out. And of course, as always, we could apply any mathematical operation we want to one side of the equation as long as we do the exact same thing to the other side. All right, so let me rewrite the problem a little larger down here. X equals w plus y plus z, all divided by 5. All right, so we see a fraction. The fraction has 5 in the denominator, and that fraction means division. So we can eliminate that dividing by 5 on the right by multiplying by 5 on the right. And whatever we do to one side, we have to also do to the other side. So on the right-hand side, the times 5 and the divide by 5 will cancel. And on the right-hand side of the equal sign, we're left with w plus y plus z. And on the left, we have now 5 times x. Okay, so we've eliminated the 5. Now we have to eliminate the w and the z. And now we could apply the addition rule. So we have a w here and a z here. So the opposite of positive w is a minus w. So we could subtract w from the right-hand side, and we could subtract w from the left-hand side. I'm going to do this one step at a time. You could do the w and the z both at the same time, but I'm going to go one step at a time. So the positive w, the negative w, they cancel. So on the right-hand side of the equal sign, we're left with the y plus the z. And on the left, well, these are not like terms. You can't combine the x's and the w's. So we simply have 5x minus w. All right, so now to get y by itself, one more thing to do here. We have to get rid of that plus z, and the opposite of a plus z is a, let's go back to red, is a minus z. And if we subtract z from the right, we must subtract z from the left. And that will give us what we want. On the right-hand side, the plus z and the minus z, they cancel, leaving us with the y. And on the left, we have a 5x, we have a minus w, and we have a minus z. And we've finished the problem because we have solved for y, or we have isolated the y. All right, number 2. So in number 2, we're given a problem very similar to number 1. Here's the equation that converts Fahrenheit to Celsius, or actually converts Celsius to Fahrenheit. And we want to solve this equation for C. Get C by itself. So we have a C right here. We want to isolate that C, and we want an equation that looks like C equals something. Okay, so again, let me rewrite the problem. 9 over 5 times C plus 32. All right, so there's a 9, there's a 5, there's a 32. We need to eliminate these numbers on the right, or basically move those to the left. So let's deal with the plus 32 first. To get rid of that plus 32, we can subtract 32 from the right-hand side. And again, whatever we do to the right, we must do to the left. All right, on the right, we have a plus 32, a minus 32. They cancel, leaving us with 9 over 5 times c. And on the left, well, f is a variable, 32 is a number. We can't combine those, so we're simply left with f minus 32. I'm going to rewrite this again. I'm just going to copy it so we have it twice. F minus 32 equals 9 over 5 times c. And the reason I'm rewriting it is because there's a couple of things we could do here. We have to get c by itself. We have to isolate the c, which means we have to get rid of that fraction 9/5 that's being multiplied by the c. Now we could do this in one step, or we could do this in two. You could look at the 9/5 as a single fraction that you could get rid of in one step, or you can look at the, I'm going to actually erase the 9/5 c, and instead of 9/5 times c, you could look at that as 9c on top and 5 on the bottom. So when you have a fraction multiplied by that variable c, the c is multiplying by the top, because 9 over 5 times c is the same as 9 over 5 times c over 1. So we have 9 times c on the top, and we have 5 times 1 on the bottom. Okay, so that's what's going on here on the right-hand side. So if we were going to do it in one step, to get rid of a times 9/5, we could divide by 9/5, or think about it as multiplying by the reciprocal 5 over 9. And whatever we do to the left, we have to do to the right. And so the 5 on top cancels the 5 on the bottom, the 9 on top cancels the 9 on the bottom, leaving us with c. And then on the left, we could just leave it as is, 5 over 9, parentheses, f minus 32. And there's our equation. We've got c by itself. Now, rather than working with the fractions, the other option is to look at the fraction as two separate numbers. The numerator is multiplication, that's the 9, and the denominator is division, that's the 5. So we can, let's get rid of that 5. Let's get just the over 5 part of the fraction. So we can multiply the right-hand side by 5. We can multiply the left-hand side by 5. So on the right, the times 5, the divide by 5 cancel, and we're left with 9 times c. And on the right, or sorry, on the left, we can multiply 5 times f, and 5 times the minus 32. So 5 times f is 5f, and 5 times a minus 32 is a minus 160. Now we have 9c on the right, so to eliminate that multiplication by 9, or the times 9, we will divide by 9. So divide both sides by 9. So on the right, the times 9, the divide by 9, they cancel. And so on the right-hand side, we're left simply with c, which is what we wanted. And on the right, we could simply say 5f minus 160 divided by 9. Both of these answers are correct. Neither one is more correct than the other. They just look a little bit different, but they mean exactly the same thing. Okay, so I just wanted to point out that my solution is not the only way to do things, and many times I'll solve the same problem a couple different ways just to give extra perspective. All right, so let's do one more problem, and it'll be a continuation of problem 2. So I'm going to go ahead and leave the answer up there. So let's Yeah, let's bring this number 3 over. In order for a chemical reaction to take place, the Fahrenheit temperature of the reagents must be at least 187.48 degrees Fahrenheit. Find the Celsius temperature at which the reaction may occur. Refer to problem 2 for the formula for Fahrenheit and round to the nearest hundredth of a degree. Okay, there's a lot going on here, but we could pull out the important information. Find the Celsius temperature. So that's what we're looking for, Celsius temperature. We don't know. For which the Fahrenheit temperature must be at least 187.48. Okay, so we're given a Fahrenheit temperature. We need the Celsius temperature. So it says refer to problem 2. Let me scroll back up to the full problem 2. We have 2 equations that we could use. We have this one, given in the original problem, and we have this one in our solution. Now we could use either one of those solutions. Or both give you the same answer. I'll use the one on the right because I like, it doesn't matter. It's just my preference. Okay, so which one? Do we want the F equals version or do we want the C equals version? Well, we want the C equals version because C is what we're looking for. So the question number 3 is asking what is the value of C? And we have an equation. C is equal to 5 times F minus 160 divided by 9. So this is the other topic in this section. So we had evaluating formulas, meaning plugging numbers in, and we had solving formulas, meaning rearranging those formulas. So we have to evaluate this formula. What we're doing is basically taking this number, 187.48, and plugging it in for that F. So instead of 5 times F, we have 5 times 187.48 minus 160, all divided by 9. And that is certainly a question for the calculator. And I'm going to pull up the Desmos calculator, which I recommend for this class. Okay, and just type it in exactly. So let me scroll over a little bit so we can see both. Type it into the calculator as exactly as you see it on the screen. So 5 parentheses 187.48 close the parentheses minus 160. Let's actually put the whole numerator in parentheses. So I'll put a parenthesis there and a parenthesis there. Okay, so that's the whole numerator of the fraction. And then we'll divide that, so backslash, divide that by 9. And if I bring this over, we see that once we plug in 187.48 in for the variable F, we get 86.37 with the 7s repeating. And since we're rounding that to the nearest hundredth, okay, let's center this. Since the directions say round to the nearest hundredth, it will be 86.3, let's say 7, the 7s go on. So rounding it to the nearest hundredth would be 86 point, hundredth is 2 decimal places. This is bigger than 5, so that means we round up. So 86.38 degrees Celsius. And that would be our final answer for the problem. All right, I will solve the other 3 problems on this worksheet in a separate video.